Hello guys, we are starting with the chapter of continuity. In our in our regular classroom sessions, we have completed this particular chapter. So it's a revision of the same that we'll be doing right now. Okay, so initially I'll be doing the problems which are less complicated, but then as and when the sessions will increase on this particular topic, the complexity of the problems will increase. Okay. So the name of the chapter is continuity and differentiability of functions. Okay, so go to your exercise 7A. Exercise 7A of the chapter. Let's go to the first problem. So the function f of x is equal to 2x square minus 1. And we have to discuss the continuity at x is equal to 3. Okay, so we'll first find out left hand side limit, LHL, limit x approaching 3 minus. Okay, so 3 is over here and we are going to reduce 3 by a very small value. Okay, so we are going to subtract a very small value from 3, that is h. So h is a very small value such that 3 is reduced to 2.99999 and something like this. Okay, so in the LHL part we have to take 3 minus left hand side limit because 3 is going to get reduced. The function remains the same, 2x square minus 1. Okay, now understand this procedure clearly. Let x is equal to 3 minus h. We are reducing 3. As x approaches 3, h will approach 0. So limit h approaches 0. Okay. 2 into, replace this x with 3 minus h. Now many people will be wondering why h is approaching 0. See, the moment when x becomes 3, so 3 and 3 gets cancelled. So minus h is equal to 0, that implies h is equal to 0. So the moment when x becomes 3, h will become 0. Okay, now there is no denominator over here, no need to simplify this further. Okay, so you can directly put the value of h as 0. So 3 square, that is 9, 9 into 2, 18, minus 1, which is equal to 17. This was the left hand side. Let us start with the right hand side limit. RHL, limit x approaching 3 plus. So we are increasing value of 3 not very drastically. So we are adding a very small value h to 3 such that x is not exactly equal to 3, but then it is very near to 3. Okay, from the right hand side. So 2x square minus 3. So this is equal to limit. Okay, now let x is equal to 3 plus h. We are increasing the value of 3 by a small value, that is h. As x approaches 3, h will approach 0. So this means h is approaching 3 and this will be 0 plus h the whole square minus 3. So wherever there is x, put 0 plus h. Okay, so 2 into 0 plus 0 the sorry, I'm really sorry, 3 plus h the whole square. Okay, so 3 into 0 the whole square minus 3. No need to simplify with this because there is no denominator. No need to worry about that. Okay, and this will be 9 into 2, 18, 18 minus 3. That will be 15. Let me go back to the previous slide, just wait. Okay, 2x square minus 1 is the function, I'm sorry. So the function is 2x square minus 1. Okay. So this is 1 over here and this will be 17. Now when x is exactly equal to 3, when x is exactly equal to 3, the function will be 2x square minus 1, but then here you have to put the value of x as 3. Okay, so 9 into 2, that is 18 minus 1, which is 17. So guys, the final conclusion is LHL equal to RHL, which is equal to f of x equal to 3, because all three values are 17. Okay, therefore f of x is continuous at x equal to 3. That's the conclusion. So that was question number 1 from exercise 7a. Okay, let us start with question number 3, exercise 7a. Fine. I'll write a few things for you. So f of x, this is question number 3, exercise 7a. F of x is equal to x square minus 4x plus 3 upon x square minus 1. Okay, this is when x is not equal to 1 and the value of f of x is equal to 2 when x is equal to 1, right? So now see guys, we have to discuss the continuity at x is equal to 1. It's given in the problem. Okay, now first part that we are supposed to focus is on LHL, left hand side limit. So limit x approaches 1 minus, we are discussing the continuity at 1, so we have to reduce the value of 1 by a very small value. Okay, so x approaches 1 minus. Okay, so see now, for x approaching 1, x is approaching 1. Okay, whether it be plus or minus, we have to take this function x square minus 4x plus 3 upon x square minus 1, because x is not exactly equal to 1, it is very near to 1. So x approaching 1 minus, we have to take the x square minus 4x plus 3 function. So this is x square minus 4x plus 3 upon x square minus 1. Now if you recollect the previous problem we have done, let x is equal to value minus h, the value is 1. So 1 is going to get reduced by h. As x approaches 1, h will approach 0. So the same thing can be written as limit h approaching 0, 1 minus h the whole square minus 4 into 1 minus h plus 3 upon 1 minus h the whole square minus 1. Now this time there is a denominator as well. So let's not keep it as it is. We have to simplify this. So 1 minus 2h plus h square minus 4 plus 4h plus 3 upon 1 minus 2h plus h square minus 1. Okay, now some cancellations will do. 1 and 1 is gone, and here 3 plus 1, that is 4, 4 and minus 4 is gone. So in the numerator we are left with h square minus 2h, and denominator also h square minus 2h. Right guys? So h square minus 2h in the numerator, h square minus 2h in the denominator. So limit h approaching 0, h square minus 2h, h square minus 2h, h approaching 0. This is getting cancelled, limit of a constant is constant. So the left hand side limit is 1. Now the right hand side limit, limit x approaching 1 plus, okay, x square minus 4x plus 3 upon x square minus 1. Okay, so let x is equal to 1 plus h this time for RHL. As x approaches 1, h will also approach 0. So limit h approaching 0, 1 plus h the whole square minus 4 into 1 plus h plus 3 upon 1 plus h the whole square minus 1. Okay. So as you have noticed in the previous problem, in the previous part, we have expanded this because there is a denominator. So right now also I will just expand this. So limit h approaching 0, 1 plus 2h plus h square. I'm just expanding the numerator over here. Minus 4 minus 4h plus 3. Minus 4 minus 4h plus 3. Okay. I hope you are observing. Upon 1 plus 2h plus h square minus 1. Now some cancellations are happening over here. Okay, so 3 plus 1, that is 4 minus 4, that is gone. Okay, and limit h approaching 0. In the numerator, it is going to be h square minus 2h. And in the denominator, h square plus 2h. Okay, let me see whether I have written this correctly or not. Just a second. Okay, so fair enough. So limit h approaching 0, take h common, h minus 2, take h common, h plus 2. So h and h is getting cancelled. Okay, now we can put the value of 0, h as 0 whenever all simplifications is done. Whenever all simplifications are done, we are supposed to put the value of h as whatever it is in the problem. Okay, minus 2 upon 2, which is equal to minus 1. So LHL is not equal to RHL. Therefore, f of x is discontinuous at, it is discontinuous at x equal to 1. Okay, that was your question number 3. Let us go to question number 5 of your textbook. So f of x is equal to uh, one second, not 5, but then I would prefer some other problem. Let's go to question number 6, sub question B. 5 involves something more which I am yet to teach you or revise. So basically, let's go to question number 6, sub question B. Uh, so we have to discuss the continuity or discontinuity at x equal to 0. Okay, so they are very specific that we have to check the continuity at x equal to 0. So f of x is equal to 2x plus 1. Okay, for x is less than 0, and f of x is equal to 2x plus 1. The earlier one is minus, I'm sorry. Okay, and this is for x is greater than or equal to 0. Okay, so x is less than 0 means the values which are negative. Okay, less than 0 and greater than 0 are the positive and the 0 values. Yeah, so we have to discuss the continuity at x is equal to 0. So left hand side limit x approaching 0 minus. Okay, now when I say 0 minus, 0 is going to get reduced. So when 0 gets reduced, it is x less than 0. And always remember, the less than sign is for left hand side. Okay, left hand side limit. So x less than 0, which function is there? 2x minus 1. So let x is equal to 0 minus h, because we are reducing the value of 0 by a very small value, that is h. As x approaches 0, h will also approach 0. Okay, so limit h approaching 0, 2 into x. X is what? 0 minus h minus 1. Okay, so look at this now, guys. There is no denominator, so we can directly put the value of h as 0. So this is equal to minus 1. The answer is minus 1 for LHL. Right hand side limit x approaching 0 plus, we are discussing the continuity at x equal to 0. It's mentioned in the problem. Okay, so for 0 plus, meaning is x is greater than 0. Okay, when 0 is increased, so x becomes greater than 0. So x is greater than 0, we will take a look at the function. For greater than 0, it is 2x plus 1. Okay, so let x is equal to 0 plus h. As x approaches 0, h is also approaching 0. So limit h approaching 0, 2 into 0 plus h plus 1. So 2 into 0 plus 0, no denominator, so no need to worry. So this is 1. So LHL is not equal to RHL. Therefore, it is discontinuous. At which point? At point x is equal to 0. At x equal to 0, it becomes discontinuous. Okay. Let us go to question number 6D. Question number 6D. Fine. So f of x is equal to 5x minus 4, 0 less than x less than or equal to 1, and f of x is equal to 4x cube minus 3x. Okay, so x is less than 1 and less than or equal to 2. So these are the intervals present, and we need to check the value of continuity at x equal to 1. They have mentioned in the problem. You should always read the problem very clearly. So we have to discuss the continuity at x is equal to 1. Now see, guys, right hand side limit or left hand side limit. Left hand side limit is equal to limit x approaching 1 minus. So 1 minus, the meaning of 1 minus is x less than 1, because when we reduce the value of 1, it will become lesser than 1. Okay, so x less than 1, we have to take this function 5x minus 4. Okay, so let x is equal to 1 minus h. As x approaches 1, h will approach 0. So limit h approaching 0, 5 into 1 minus h minus 4. Okay, now there is no denominator, no need to simplify this further. So this is going to be 5 minus 4, that is equal to 1. This is your left hand side limit. Now let's take a look at the right hand side limit. Limit x approaching 1 plus, where x is greater than 1. Okay, 1 plus, we are increasing the value of x, so it becomes greater than 1. Okay, when we increase the value of x as 1, when we are increasing 1, so it becomes greater than 1, right? So greater than 1, which function is there? X greater than 1. This is x greater than 1. 1 is lesser than x, meaning x is greater than 1. So that is 4x cube minus 3x. 4x cube minus 3x. 1 second. So let x is equal to 1 plus h. As x approaches 1, h will approach 0. So this is going to be limit h approaching 0. 4 into 1 plus h the whole cube, 3 into 1 plus h. Limit h approaching 0. Okay, no need to simplify this because there is no denominator. Okay, so 4 into 1 plus 0 the whole cube, 3 into 1 plus 0. So 4 minus 3, that is equal to 1. Now if you take a look at LHL and RHL, both are same, but then here we need to check the third thing also. F of x exactly equal to 1. Earlier two were very near to 1, but then this is exactly equal to 1. So when I say exactly equal to 1, it is again this function 5x minus 4. Okay, so when LHL and RHL are equal, you have to check the third thing also. So 5x minus 4. So put x equal to 1, exactly equal to 1. So this is also 1. So LHL equal to RHL equal to f of x equal to 1. So f of x is continuous at x equal to 1. So that is our solution. Question 6, sub question D it was. Okay. Let's go to question number 8. Question number 8. So we have to discuss the continuity at x is equal to half. So f of x is equal to half plus x. F of x is equal to 1 and f of x is equal to 3 by 2 plus x. Okay. Now the first function is true when x is between 0 to half. Second is when x is equal to half. And third one is when x is between half and 1. Okay. Now we have to discuss the continuity at half. So left hand side limit x approaching half minus. Okay, minus is always left hand side. Meaning of half minus is x is less than half. Okay, so when I say x is less than half, x is less than half, it is this function half plus x. Okay, so here I'll just write half plus x. Let x is equal to half minus h. As x approaches half, h will approach 0. So limit h approaches 0, half plus half minus h. The value of x is half minus h. Now there is no denominator, so what we'll do is we are going to put the value of h as 0. So this is going to be 1. So this is the left hand side. Let's go to the right hand side limit. Limit x approaching 1 half plus half plus. Okay. So half plus is more than the value of half, that is greater than half. So when I say x is greater than half, it is this function 3 by 2. Okay, 3 by 2 plus x. So this is 3 by 2 plus x. As x approaches, 1 second, let x is equal to half plus h. As x approaches half, h will approach 0. So this is going to limit h approaching 0, 3 by 2 plus half plus h. Replace the value of x with half plus h. So 3 by 2 plus half plus 0. So 4 by 2, that is equal to 2. Now in this case, so LHL, obviously it is not equal to RHL. 1 is not equal to 2. So it is discontinuous. You can just frame it up over here. LHL not equal to RHL. Therefore, f of x is discontinuous at x is equal to half. This was your question number 8. Okay, so let us continue with problem number 13. Okay, now before we start with problem number 13, what we need to understand is in our earlier standard, we had done this two formulae. Sin x upon x is equal to 1 and limit x approaching 0, tan x upon x, it is equal to 1. These are the two very important formulae that we have to remember. These two formulae are applicable only for sine and tan and not for any other trigonometric functions. And one more thing you need to remember, if it is x over here, down also it should be x. If it is 2x in the top, down also it should be 2x. If it is 3x, down also it should be 3x. So this is the nature of the formula. So we'll solve a problem based on this. Question number 13, A part. Okay, 13A part, we are just doing it right now. Fine. So f of x is equal to tan 2x upon 3x when x is not equal to 0, means it can be greater than or less than 0, but then exactly not equal to 0. F of x is equal to 0. F of x is equal to 2 by 3 when x is equal to 0. So left hand side limit x approaching 0 minus. We have to discuss the continuity at x equal to 0. It's clearly mentioned in the problem. So 0 minus can be greater than or lesser than, but then not equal to 0. Okay. Tan 2x upon 3x. Let x is equal to 0 minus h. As x approaches 0, h will also approach 0. So limit h approaching 0, tan 2 into 0 minus h upon 3 into 0 minus h. Now 0 minus h is minus h, so the angle for tan will become minus 2h. So let's go to the next slide. So this is equal to limit h approaching 0, tan minus 2h upon minus 3h. Okay. Now tan of any negative angle is, the minus sign goes out. Tan of minus x is minus tan x. That concept I'm using. Okay. So this minus and minus goes. Now we can apply the formula over here provided the angle remains same. So the angle is 2h. Tan 2h, the angle is 2h. Down also we require the angle as 2h. Down also we require the angle as 2h. So we'll just separate 3. We'll just separate 3. Okay. And since we require 2h over here, down 2, we'll multiply 2 and we'll divide 2. To nullify the 2, we have to put it in the numerator also. Okay. So minus and minus sign goes, 3 is eliminated. We need to get 2h in the denominator. H is already there. So we are just placing 2 over here and here. Fine. So now this part, as per the formula, this part is equal to 0. Okay. This part is equal to 0. Okay. This part is equal to 1. I'm sorry. Because h is also approaching 0. And you need to write one statement over here. Be on the safer side and write as h approaches 0, 2h will also approach 0. Okay. So this part is 1. 1 into 2 by 3, which is equal to 2 by 3. This is your left hand side of the limit. Let's go to the right hand side of the limit. Okay. So the right hand side, RHL limit x approaching 0 plus. The function remains same, tan 2x upon 3x. Okay. Now why the function remains same is because when I say x is not equal to 0, it can be greater than or less than 0. But then exactly it cannot be equal to 0. Okay. Let x is equal to 0 plus h. As x approaches 0, as x approaches 0, h will also approach 0. So limit h approaching 0, tan 2 into 0 plus h, 3 into 0 plus h. Limit h approaching 0, tan 2h upon 3h. Now once again, 2h is over here, down also we require 2h. So first thing, what we are going to do is we are going to eliminate the 3. Okay, h is already there. So eliminate 3. Don't write 3 along with h. Now 2h is there, so we'll make this 2 and we'll write 2 over here. Okay, now this part is 1 because h is approaching 0. So write that h approaches 0, so 2h also approaches 0. Okay, so this part is 1 as per the formula into constant 2 by 3. So this is also equal to 2 by 3. Now let's check our left hand side as well. Yes, it's 2 by 3. So final conclusion, what we can give is, okay, final conclusion is for this problem. See, f of x equal to 0 is already there, 2 by 3. We need not calculate it, it's 2 by 3. So we can write LHL equal to RHL is equal to f of x equal to 0. All values are 2 by 3. Therefore, f of x is continuous at x equal to 0. So that should be your conclusion. Okay. So I think this much is enough for you to understand in session number 1. Practice these problems. Okay. I'll see you in session number 2. Bye.